Hello friends, welcome to Susan and John Matthew. This is lesson number 2 and in this video we're going to learn how to solve partial differential equation using separation of variables. Okay, before we start, we have to do a small revision and you have to be very clear about all the methods of solving differential equation which you learned in your first semester and in your high school. Anyway, I'll give you a small revision for second order differential equation with constant coefficient and right side 0. Do you remember in your first semester you learned right side with e power ax, sin ax, polynomial and product of these things etc etc. But we don't need all those things. We need the one with right side equal to 0. And the method goes like this. We will write something called auxiliary equation. If you still don't remember, you can check those videos. Okay, anyway, we write the auxiliary equation. That means replace every d with m and solve the auxiliary equation. And when you solve, there are three possibilities. The roots can be distinct, like 3 and 1, or minus 1 by 2 and 7. Then the ready-made solution is this. And the roots can be equal, then the ready-made solution is this. Some of you might have learned method of undetermined coefficient. If you know that method, you can apply, but that will make the process very long. This is more efficient because as an engineering student, your aim is to get the solution as soon as possible. And if the roots are complex, something like alpha plus I beta, alpha plus minus I beta, then this will be the solution. Anyway, let's go for the problem. Solve the differential equation uxx. Can you see? Del square u by del x square, the second order derivative, minus 2 u suffix x plus uy equal to 0. Okay, so in every problem which is in the standard form, what we do is we write, let the solution be. Do you remember what is a solution? Solution is a function which will balance the equation. So I am going to write, let the solution be x multiplied by y. Can you see? U is a function which depends on x and y. So I am going to write, let this be the solution where x is a function in x and y is a function in y. Once more I'll repeat. If you see the linear standard form, then in every problem or if the boundary conditions are rectangular conditions, which you will understand very soon, we can apply this method. Okay, now remember solution will balance an equation. Come on, let's consider a quadratic equation x square minus 4 equal to 0. This is not a differential equation, but I want to show you solution will balance an equation. Come on, the solutions are x equal to 2 and minus 2, which you learned long back. But we call them solution because it is going to balance it. Can you see 2 square minus 4 or minus 2 the whole square minus 4? Similarly, if you have a trigonometric equation, something like sin x equal to 1 by 2, x equal to 30 degree, x equal to 150 degree, you plug in any value, you will get 1 by 2 equal to 1 by 2. Now, even consider a differential equation, something like dy by dx equal to y. I know the answer. The solution is the function y equal to e power x. Come on, the derivative of e power x is e power x. Can you see? So, solution will balance the equation. So, I'm going to plug it back. Now, look at this. Del square u by the way, let's call it equation number 1 because at the last we have to plug it here. So del square u by del x square. That means I'm going to differentiate this partially with respect to x. So that will be x double dash y. Understand very clearly. If you understand one problem, all the problems will look alike. Now, I want the second term del u by del x. What do you mean by del u by del x? It means I am differentiating partially with respect to x. That means I'm going to treat y as a constant, so I'll get x dash into y. Okay, now what will be del u by del y? Del u by del y means now y is the hero. So I'm going to get x y dash. Anyway, I'm going to plug everything into the equation. So I will eventually get x double dash y minus 2x dash y plus x into y dash equal to 0. Okay, I know some of you are confused. Wait a minute. We are given a second order equation. I am assuming let this be the solution because I know all the solutions will come in product form if it is that linear equation. Now, solution will balance the equation. Can you see? I am plugging the solution into the equation. So, when you plug in x into y here, I am differentiating 2 times, and that is how I got this part. Now, you have to manipulate it a little bit. When you work out 3, 4, 5, 6 problems, you'll understand the technique. Anyway, I'll do it for you. So I'm going to write this as x double dash y minus 2x dash into y equal to x into y dash with a negative. I did that intentionally because I saw something is common here. That is x double dash minus 2x dash, and I took common that y. Can you see y is common? Is equal to x into y dash. That is x double dash minus 2x dash divided by x is equal to minus y dash by y. So what I did is I made all the terms in x to one side. Do you remember the name of the method? Separation of variable. And I kept all the terms in y to the other side, and I'm going to equate it to a constant. I'm going to call it lambda. By the way, calling it a constant is not correct. To be honest, you should call it parameter. If you want, you can give t also, but usually we don't use t just for the reason uh, in many wave equation problem, heat equation problem, etc., t might be time, temperature, so there will be confusion. So it's better to keep k, lambda, etc. And by the way, it has to be a constant because when one variable is equal to another function or one function equal to another function, it will automatically become a constant. There is no other option. It cannot stay as a variable. So this ratio is equal to constant and this ratio is equal to constant. So we end up like x double dash minus 2x dash by x is equal to lambda and minus y dash by y is equal to lambda. Once more, what we are doing is we are assuming our solution to be x into y. So we are going to hunt and find the values of x and y. Don't forget, we are assuming the solution to be x multiplied by y. And finally, we are almost near that part. So I'm going to convert this into an equation. So I'll get x double dash minus 2x dash minus lambda x equal to 0. I hope I didn't confuse you. I cross multiplied and took that to this side. And here I'll get y dash is equal to minus lambda into y. Okay, so let's continue with this. So let's focus only on this equation. I'm going to write this as d square x. Do you remember the one which you learned in first semester? Minus 2 dx minus lambda x is equal to 0. So d square minus 2d minus lambda of x equal to 0. Come on, tell me the method. If you don't remember the method, you can pause the video and go to the first part of the video. If you're still not confident, you can go to the first semester video. Anyway, we write something called auxiliary equation m square minus 2m minus lambda equal to 0 and solve it. We cannot use calculator, we have to use the formula method. Minus b plus minus root under b square minus 4 into 1 into minus lambda, the whole divided by 1 into 2. So m equal to 2 plus minus, this 4 will come common, it will become 2 root under 1 plus lambda divided by 2. Again 2 comes common. I hope you are working out along with me. So pause the video and solve it patiently. Because when you try it yourself, it will make sense. So you'll get 1 plus minus root under 1 plus lambda. Now look at this. If you want, you can keep it like this. But I hate this root under, like what you call it, it looks clumsy. So what I'm going to do is, I'm going to put 1 plus lambda equal to a square. Once more I'll repeat. If you want, you can keep it like this, no problem. But I want to escape from the square root, so I'm going to call it lambda. Once more, this step is not compulsory. I'm doing it so that the answer looks beautiful. So I'll get m equal to 1 plus minus a. You understood, right? Because I put the quantity under the square root as a square. So I got this. So I get 1 plus a, 1 minus a. Let's go back and check. This is something from your first semester. If the roots are distinct, then the solution will be this. Okay, so the solution, that means I got the x value. So x equal to c1 e to the power 1 plus a into x plus c2 e to the power 1 minus a into x. So let's call it equation number 2. Once more I'll repeat. We are trying to find x and y because our solution is x multiplied by y. Now where is our equation in y? This is our equation in y. So we have this equation, differential equation y dash equal to minus lambda y. That means dy by dy, because y is a function in small y, equal to minus lambda y. It is 100% variable separable. So dy by y equal to minus lambda dy, integrating. So integrating 1 by y, we get log y equal to minus lambda into y plus c3. We already use c1 and c2. So y is equal to e to the power minus lambda y plus c3. So y is equal to e to the power minus lambda y into e to the power c3. Because a power m plus n is a power m times a power n. And this can be called as another constant. I'm going to call it c3 itself. If you want, you can call it c lambda y, and that's it. We are done. Come on, now we get the solution. What is the solution? U is equal to x into y. We already found x. What is the value of x? So we get c1 e to the power 1 plus a into x plus c2 e to the power 1 minus a into x multiplied by c3 e to the power minus lambda into y. If you want, you can leave it like this. No problem with that. If you want, you can leave it like this. And do you remember, we called 1 plus lambda equal to a square. But I have a very good idea. What I'm going to do is, I'm going to take this constant inside. Once more, if you leave it like this, you will get full mark. But still, let's manipulate it a little bit. So u equal to c1 c3 e to the power 1 plus a into x plus c2 c3 e to the power 1 minus a into x multiplied by e power minus lambda y. Now I'm going to call this 1 plus a as m and 1 minus a as n and c1 c3 as a, c2 c3 as b. And now look at this. Can you see, if I multiply 1 plus a and 1 minus a, I'm going to get 1 minus a square is equal to m into n. And that is exactly, can you see this, 1 minus a square equal to minus lambda. So minus lambda equal to m into n. So if you do this much, your equation or the final answer looks cute. It is going to look a e power m into x plus b e power n into x, n into x, the whole multiplied by e to the power minus will be m in into y. So if you want, you can make it cute, or if you do not want to do this step, you leave it here itself. Now let's go for another problem, and that is extra important because it has boundary condition. So please write, solve the differential equation del u by del x, or dou u by dou x, or partial derivative with respect to x, is equal to 2 del u by del t plus u with boundary condition x comma 0 is equal to 6 e power minus 3x. Now look at this. In our previous problem, they did not give us any boundary condition. So our answer is incomplete, or we kept our answer in arbitrary constant, or in other words, practically this solution does not have any use. So to make the solution fruitful, we need something called initial condition, final condition, or the boundary condition. So whenever they give you boundary condition, you have to find the value of the constant. Anyway, what is the method? If it is linear, then you assume let the solution be x into t. Why did I put it x into t? Because u is a function in x and t in this problem, where x equal to a function in x, t is equal to a function in t. Okay, now solution will balance the equation. So can you tell me what will be dou u by dou x, or del u by del x? X dash into t is equal to 2 x into t dash plus x into t. Okay, now what will you do? You have to separate the variable. I can already see one advantage. So what I'm going to do is I'm going to write x dash into t is equal to, there's something common here. So 2t dash plus t. That means x dash divided by x is equal to 2t dash plus t divided by t. Once more, when a function in x is equal to function in t, the ratio cannot be a function anymore. It has to be a constant. Think about it. And actually, calling it a constant is not correct. It will be a parameter. Parameter means problem to problem, the value will change. But currently, it is a constant. Okay, so x dash by x is equal to lambda. See, I got it completely in x. 2t dash plus t by t is equal to lambda. Now I'm 100% sure, compared to the first question, you will understand a little bit more. Okay, so I'm going to solve it side by side. X dash equal to lambda x, and here I'm going to get 2t dash by t plus t by t is 1. Come on, what is a plus b by c? Isn't it a by c plus b by c? So this will become plus 1 equal to lambda, and that means dx by dx is equal to lambda into x, and here we will get 2t dash by t is equal to lambda minus 1. That means t dash by t is equal to half into lambda minus 1. So t dash is equal to half lambda minus 1 t, and we are going to get something very similar. So I'm going to write this as dx by x is equal to lambda into small dx, and here it will be dt by d small t is equal to 1 by 2 lambda minus 1 into t, and here integrating gives us log x equal to lambda x plus c1. And you saw previously, if you want I can write all the steps, but I want you to try it yourself. We'll end up like x equal to c1 e power lambda x. And here, if you integrate, you have to take it to this side, that side, etc. You're going to get t is equal to c2 e to the power 1 by 2 into lambda minus 1 into t. Comment below whether you got the same answer or not. Now wait a minute, you cannot stop here. Don't be too happy. This is a problem with boundary condition. Anyway, first of all, let's be very happy about one thing. We got the solution. So you can write the solution. The solution is u is equal to x into t. That is u is equal to, the value of x is c1 e power lambda x, and t is c2 e to the power lambda minus 1 divided by 2 into t. Can you see that 1 by 2 into lambda minus 1 is lambda minus 1 by t. That is u is equal to c1 c2 e to the power, what is a power m times a power n, a power m plus n. So I'm going to add lambda x plus lambda minus 1 by 2 into t. That is u is equal to c e power lambda x plus lambda minus 1 by 2 into t. Now our equation looks kind of cute. Okay, but wait a minute. If you leave it here, you lose mark. 100% sure you lose mark. The reason is they have given a boundary condition. So it is given ux0 is equal to 6 into e power minus 3x. That means the value of u is this function when x equal to x and t equal to 0. So here I can replace this u with 6 e power minus 3x is equal to constant multiplied by, what should I do instead of x? Keep x. What should I do instead of t? I have to plug in 0. So lambda minus 1 into 0 will be 0. Gone. Comparing both sides, c equal to 6 and lambda equal to minus 3. Now let's plug it back. So when you plug it back, u will become c into e power minus 3x, and you put minus 3 minus 1, that will be minus 4 by 2 minus 2t. That's it. So this is the final particular solution. I hope you remember the name. This one is called general solution and this is called particular solution. So I'll be back with two more problems like this, which is very important, and then we will start with modeling wave equation. So till then, my friends,